So let's say we're asked to solve for the side or an angle of a non-right triangle. How would we approach this? So this, for example, is a non-right triangle, which means that the trig ratios don't actually apply. So what we would do is, the first thing you do is split it into two right triangles, because then you can apply the trig ratios to each right triangle separately. So if I'm thinking of this question here, I could solve this one in purple independently, and then I can use that information to solve the neighboring triangle afterwards. And what I mean by that is, if you look here, they have a shared side. So I'm going to use the purple triangle to get the shared side, and then that's going to allow me to solve for everything else that I need in the other triangle. So from the first triangle here, that's my angle, which means that the side that is opposite to that, the 9, would be the opposite side, and that is the hypotenuse. It's always the longest slanted side, so that makes the shared side the adjacent. And when I think back to my SOHCAHTOA, right, my acronym that, or my mnemonic that quickly sums up the formulas for us, we're looking for a formula in which the opposite and the adjacent are both accounted for, since I want to solve for the adjacent using the opposite. And that would be the tan formula here. So to get the shared side, I'm going to go tan 35 is equal to my opposite, which is 9, over my adjacent, and that's what's unknown. So we're going to call that x. Now I'm going to isolate for x by multiplying x on both sides here. And then that leaves me with x times tan 35 is equal to 9. And then I'm going to divide both sides by tan 35. And then when you plug that into your calculator, you should be getting, and make sure your calculator is in degree mode, by the way, you should be getting this value here, about 12.85. So that's the shared side here. Now what we could do is, if we have the shared side, so I could change this to now, that'll be a 12.85. So I'll just put a little arrow here, going 12.85. So now I can use this side in order to get this side here. And if I redraw the triangle so it's a bit easier to see, basically what I have is something like this, where I have 12.85 here, 61 there, and I want to solve for x, which is the opposite side. So that would be the hypotenuse. And if that's the opposite side, then that would make this the adjacent side. So I want another formula, again, that deals with opposite and adjacent. So that would once again be tan. So we would go tan 61 is equal to opposite over adjacent, which was the 12.85. And then like I did last time, I'm going to multiply both sides by 12.85 in order to isolate for my x. And so when I plug it in here, and I go tan 61 times 12.85, I get a value of about, I'm going to write it in purple underneath here, 23.2. So let's say here we're asked to find the area of each triangle here. Now remember that area is equal to base times height divided by 2 for a triangle. And so what we really need is the height of each of these. So this is another case where I'm going to have to use the knowledge of one triangle and find the shared side so I can find the other triangle properties. I'm given this base over here, but I would need to find out this base and then add them both up in order to find the area of this triangle. Now, if I'm given this base and I'm given this angle, the value of 46 is opposite to the 70 degrees. And then that would make this shared side between the two triangles, that would make it the adjacent side. So once again, what I could do is I can go 10, 70 degrees is equal to 46 over the adjacent side, right? SOHCAHTOA. So 10 is opposite over adjacent. And then I just simply isolate from my adjacent by multiplying both sides here and then dividing. So from my adjacent side, that's going to equal to 46 divided by 1070. And if you plug that into your calculator, you get about 16.74. So now that I have that side, 16.74, now I can erase this part here, indicate that that's 16.74, and then I can use that side with this angle to find what this missing side is going to be. So in this case, if that's the angle, then that side is the opposite, which would make this one the adjacent again. So we could use the tan formula, which is going to be tan 44 degrees equals your opposite, which is 16.74, divided by the adjacent. And then same thing like I did last time. I'm going to multiply both sides by the adjacent. And then divide both sides by 1044. And that's going to give me this for the adjacent. 16.74 divided by 1044. And then that gives me about 17.337. And so now I have this exact length. So that gives us then 46 plus 17.337, because that would be the size of the total base. And then we're going to multiply it by the height of 16.74, right over here. And so when we do that, and we go here, if I go, the area ends up being about 530.13, and that'll be, well, units squared, right? So whatever those units are, it would be this. So for this example, Evelyn Granville, who is 1.5 meters tall, is standing 20 meters from the base of a building. She sights the top of the building with an angle of elevation of 58 degrees. Find the height of the building. So a couple of things. Whenever we see the angle of elevation, if this is the ground, your angle of elevation is always going to be looking upwards, okay, towards whatever it's looking at, but it's an upwards angle with reference to the ground. And the angle of depression is the opposite. Let's say you have your building and you got your ground over here. Your angle of depression is going to be looking downwards. So imagine somebody's on top of the building looking down. This is an angle of depression. Now for this question, we want an angle of elevation. So we are going to be looking upwards. And so you got Evelyn, who is 1.5 meters tall. Okay, so this height here is 1.5. And then they're standing 20 meters away. Okay, and this is not to scale, but we're just kind of drawing it roughly here. So it's 20 meters away from the base of the building. And they're looking upwards with an angle of elevation of 58 degrees. And they want to know what's the height of this building over here. So I find that drawing these problems always help. And what we're going to do is, for this problem, we end up having kind of, a hidden triangle here. And what I can do is I can solve for this side of the triangle, given that I have the 20 meters, which would go across here. So I could solve for this side of the triangle. And then I'll just add on the 1.5 for the total height. So if we think about this here, the height, if that's the angle, the height is opposite to that, and what we have is an adjacent, then the best formula to use to solve for that small part here is the tan formula. So we would go tan 58 is equal to your height, which is your opposite, over your adjacent, which is 20 meters. And so we would just cross multiply or multiply 20 on both sides. And when we plug that into our calculator, we get 20 multiplied by tan 58. And that gives us a height of about 32 meters. Now, we're going to add that on because that's just this portion over here. For the total height, we're going to go 32 plus 1.5. Then that gives us a height of 33.5 meters. That's how tall the building is. So for this question, when a child flying a kite has let out 50 meters of string, so that would be this part over here, the string makes an angle of 55 degrees with the ground. How high is the kite? So if this is the angle, then the height, which is right across, that would be the opposite side. And then the 50 meters would be given here, right? So that would be the hypotenuse because it is the longest side that we would see. So we would go sine 55 degrees, and we're choosing sine because that's the only formula out of SOHCAHTOA that deals with both the opposite and hypotenuse. So sine 55 is equal to the height over 50, and I'm going to multiply both sides by 50. And when I plug that into the calculator, I get a value of about 41 meters.